live. Okay, so tomorrow, quiz 10, 14, 19. Okay, so there's a couple of ways to do the first one. 48 can be broken up into 4 and 12 and then broken up again, but I'm going to go straight to the biggest one, which is 16 times 3. So I'm going to go 3 square root of 16 square root of 3, because 16 times 3 is 48. Square root of 16 is 4. If I get going too fast, just ask. And then the 3 times the 4 makes a 12 with my square root of 3. That's my answer. Okay, hopefully everybody can do something like that tomorrow, okay? We did this in geometry, so this is a little bit of a review. We will get to the harder ones as we move on, but this is kind of a review of what we did last year, okay? Number 2, we're just going to multiply, and we're going to get 6 square root of 72. I'm going to multiply whole numbers and rational numbers times rational. Now 72 can be broken down 9 and 8. That'll work, but I'm going to go 36 and 2 because it's bigger numbers and it's faster, okay? God bless you. So I'm going to go square root of 36, square root of 2. I know the square root of 36 is 6. 6 times 6 is 36, so I get 36 square root of 2, okay? Again, if I get going too fast, tell me to slow down, okay? All right, 3. Well, the 7x is already out, so it's already been square rooted, so I'm going to leave the 7x out. But I'll break down the 50, and the way I want to break down the 50 is into 25 times 2. I'd like to take half the exponent, but I can't take half of an odd number. So what I'm going to do is take 1 away from it and make it even, right? So I'm going to make it a square root of x to the 8th and a square root of x. By taking 1 away from the 9, it makes an even power, and I can take half of the even power. Okay, so let's see what I have now. So I'll have a 7x. Square root of 25 is a 5. I'll take half of that and make that x to the 4th. And what's left over cannot be rooted, can't be square rooted. So I'll leave the 2 and the x inside. So I'll go square root of 2x. Finally, I'll tidy it up, and let's see what I have. I'll have a 35.
Mr. Jones,
Mm-hmm.
when you write x to the 9 and then another x, it's because it's uneven, but would you write x to the 8?
I did. Yeah, x to the 8th, the next one.
Oh,
Oh, yeah. So I'll have a 35, 7 times 5. I'll have a x to the 5th, because I have an x here, and 4 of these, x to the 5th. Square root of 2x, and that is my answer, okay? All right. Now number 4 is a cube root. Okay, so then do my cube root again. Wait, 216. I think 216 is up here. So 216 is one of my perfect roots. I go straight to 6, okay? So I'm going to go straight to 6. And then instead of taking half, we're actually going to take a third because it's cube root. I'll take a third of that. So I'll take a third of the 12, which is x to the 4th. And I'll take a third of that, which is y to the 2. That's all I have to do. That was pretty easy, huh? Okay, number 5. Again, if I get going too fast, let me know. Okay, you can only add or subtract like terms. Called like terms means you can't put an 18 and a square root of 12 together. Nor can you put a square root of 50. But if we break it up and reduce it, they might be the same. So let's take a look. So 18, the square root of 18, I'll break down into the square root of 9 times the square root of 2. I'll break down the 12 into the square root of 4, square root of 3. And I'll break down the 50 into the square root of 25 and the square root of 2. Now, if I take a look at these, and I keep breaking them down, maybe something will be the same. The square root of 9 is 3. So I got a 3 times 3, square root of 2. Minus 4, square root of 4 is 2 times square root of 3. If I break down the 25, I'll get a square root of 25 is 5 times square root of 2. Okay, I'm getting close. Looks like I'll have some square roots of 2's when I'm done. So if I multiply through, I'll get a 9 square root of 2 minus an 8 square root of 3 plus a 20 square root of 2. Okay, now I can add at least a couple of these together. So I'm going to multiply, or add. I'm going to put the 9 square root of 2 with the 20 square root of 2 and make it 29. So I'll make that up. I'm going to scoot over here because I'm running out of room. So answer, we'll put a 29, because these two can be added. Square root of 2 minus 8 square root of 3. That's all I got. So add and subtract only ones that are the same, okay? Okay, number 6. We're going to go that times that times that. Okay, we're just going to distribute. So we're going to multiply whole numbers with whole numbers. 3 times 3 is 9. Square root of 5 times square root of 5 is square root of 25. We're going to multiply again. 3 times 5 is a negative 15. Whole number with whole number times the square root of 10. All right, what can I break up? Well, the square root of 25, yeah, I sure can. Thank you. Okay, so what can I break up? Well, the 25, square root of 25 is 5. 9 times 5 is a 45. And the 10 I can't break down at all. 2 and 5 can't, so I'll leave that as minus 15 square root of 10. Okay. All right. How am I doing? Am I going too fast? Okay, 7. I'm going to multiply this times this. I'm going to get an 8 times the square root of 9. I'm going to go 4 square root of 3 times 2. Now, a lot of kids mess this up, but multiply whole numbers with whole numbers. I'm going to get 8 square root of 3. This times this makes a negative 10 square root of 3. And negative 5 times 2 makes a negative 10. Okay? All right, let's see what I got. 8 times 9 is 3. Okay, that makes that a 24. These two are the same. I can combine these two, and I'm going to get a negative 2 square root of 3 minus 10. Again, if I'm going too fast, let me know, okay? So let's combine what I know, okay? 24 minus 10 is a 14. That's a root. I can't add those, so I'm going to get minus 2 square root of 3. All right? Thumbs up so far? All right, now number 8. I see that number, which I don't see really. That number's kind of erased, but 125 is perfect. 125. See that number, and I also see the 8. Okay, so I see perfect one. So let me rewrite it as 2 parts. I'm going to rewrite it as 2 parts. Whereas the cube root of 125 times the cube root of 8. Okay?
Can't see.
Oh, thank you. So what I recognize is 2 numbers that both can be cube rooted. So the cube root of 125 is 5, and the cube root of 8 is 2. And that's all I have to do. All right, number 9. So with number 9, what I see is 2 things. I see the cube root of 27, which is a perfect root, over the cube root of 5, which is not. Scoot over. Okay, there you go. Okay, so I broke it into 2 parts. Now the cube root of 27 is just plain old 3. That's one of these special numbers. Okay, 3 times 3 times 3. So I'm going to go straight to writing that as 3 over the cube root of 5. Okay. Now, we used to learn when we were in geometry that we fix a problem with a problem, but that doesn't work with cube roots. What we have to do is make this, the bottom number, we need to make into one of these numbers, because these are the numbers that we have for the cube root, right? So when I look at 125, right? So I got to make the bottom or the denominator into 125. So what I'm going to do is multiply by the cube root of 25.
With a square root, you can fix it?
Yeah, because it makes that number squared. Yeah. So, and the cube root of 25. So what I get on the bottom, on the denominator, is I'll get the cube root of 125, which is plain old 5. And on the top, I'm going to get 3 times the cube root of 25. Don't divide these numbers, because that's not a 25. Yeah, I don't know what it is. Probably 2 point something or other. Probably 2 point something or other. You check it out for me, Lily. 2.8. I'm going to guess 2.8. Tell me what I got.
2.92.
Wow, that's close though, huh? Okay, number 10. So with 10, we're going to multiply by a thing called the conjugate. The conjugate is the opposite of that sign. So we're going to multiply top and bottom by 2 plus the square root of 6, 2 plus the square root of 6, okay? All right, that's the conjugate. So I'm going to multiply through. So in the denominator, the reason we do it is we're going to get, you ready? 4 plus 2 square roots of 6 minus 2 square roots of 6 minus the square root of 36, okay?
Can you scoot it over, please?
Yeah, I sure can. Thanks, Isaac. So I got 4 plus 2 square roots of 6 minus 2 square roots of 6 minus the square root of 36. On the numerator, I'm going to get 8 plus 4 square roots of 6, okay? Now, the reason we do the conjugate is those two cancel, okay? Let's see. And the square root of 36 is 6. So when I look at the problem now, in the denominator, there's no more square roots, right? The denominator has completely been cleared. So for the numerator, I got 8 plus 4 square roots of 6 over 4 minus 6, which is a negative 2. Now that answer's okay, but I'd rather just instead make it a negative 4 minus 2 square roots of 6 is a better answer because I just divided the negative 2 into both those, okay? Okay, so I divided, here's my negative 4, so my negative 4 and minus 2 square roots of 6 because I divided the negative 2 into both whole numbers. Whole number into whole number, okay? How am I doing, okay? You guys can do this tomorrow? Well, you did this in geometry, so this is, a lot is just review, right? Okay, 11. So with 16 to the 1/2 power, we've learned that 1/2 power is square root. So it's just really the square root of 16, which is 4. Where do you get? Audio, want to see this again? So 4 minus 6 is negative 2.
Oh.
Got it? Okay. Yeah. Okay, number 12. Okay, so what I'm going to do on 12 is rewrite it as a 1 over. Okay, negative exponent. Negative exponent, make it 1 over the 5th root of 32 to the 4th power, okay? And then the 5th root, let everybody around you learn, okay? The 5th root of 32 is 2, so I got 1 over 2 to the 4th power, and 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. I get 1 over 16. Okay. All right. 13. So what I'm going to do on 13 is I'm actually going to multiply exponents. And multiply exponents. Okay, let's see if that makes a difference. So I'm going to go 8 times 1/4. 8 times a negative 1/4 is a negative 2. So I'm going to have a 5 to the negative 2 power over 10 to the negative 1/4 power is going to be 10 to the negative 1. I just multiplied exponents. 8 times, sure. 8 times negative 1/4. 8 times negative 1/4 is a negative 2, and negative 1/4 times 4 is a negative 1. I just multiplied exponents. Now, what I know with exponents, if they're negative, they're in the wrong side, right? Negative, so I'm going to flip it. I'm going to bring the 10 to the 1 on top and the 5 to the 2 on the bottom. Okay? Now I'm going to keep going. That's the same thing as 10 over 25, which is 2/5. Okay? All right? Okay, now 14. I think there's a trick in 14 that's going to make it easy. I think if I were to divide possibly the 2 into 32, that might make it really easy for me, right? They're both cube roots. So let me do that first. Okay, so let me rewrite this as the cube root of 4 times the cube root of 16. Okay? I just divide it because 2 goes into 32, 16. And they're both cube roots, so I can do that. So then if I multiply that, I'm going to get the cube root of 64. And I think that's one of my special numbers, isn't it? 4. Yeah, it goes straight to 4, okay? So the cube root of 64 is 4 because 4 times 4 is 16 times 4 is 64, okay? Thumbs up, how am I doing?
Good.
Okay, turn the page. All right. Okay, number 15, we're going to graph. Let me grab a piece of graph paper so I can have it really nice and neat. And go really good. Okay? Graph paper. Lost all my graph paper.
I like how I have to see this. I'll go drink once. Give her
Here we go.
It was fun. Me and Joe.
You guys gotta go.
Me and Joe.
Here's homework.
Wow.
Yeah, so if I can make a suggestion for you guys, if you get here early tomorrow, like 7:30 to start the test, right? Then you won't run out of time to take it, okay? Does that make sense? So, Austin, Jay, are you leaving or not?
No, I don't have this one.
Okay, so guys, seriously, if you want to have enough time, I would get here at 7:30 and start the test at 7:30, okay? All right, so 15. Let's do 15. I just had graph paper in my hand. Okay, on 15, what I want to do is show the parent function first, okay? And the parent function looks like this. Okay, here's what the parent function looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's just the y equals the square root of x, okay? That's the parent function. Now that is not what I'm going to graph, but I'm going to move this. I'm going to do 3 things. That's my parent function. And what I'm going to do is we're going to make it upside down. We're going to flip over the x. We're going to flip over x-axis. We're also going to move it to the right 1. And then we're going to go up 3, totally right. Up 3, totally right. So let's see what happens. So I'm going to take, first of all, and move the end point to here. 1, 3. Okay. And then, actually we're going to take that. That's going to flip, and then we're going to bring it up. So then from here, it goes upside down. There's my graph.
Why wouldn't you just flip it over the...
Yeah, we do. We flip it over the x, and then we bring it up, right? Yeah. Yeah. Okay. Let's look at numbers. Oh, domain and range. So domain x is greater than or equal to 1, right? Because it starts at 1 and moves over. And the range is going to be y is less than or equal to 3. Okay, thumbs up on that? Okay. 16. You guys ready for 16? Okay, 16. First, let's look at the parent function, and then we'll move, okay? So 16, I'm going to graph the parent function. So it's nice to see the parent function, because then moving is easy. We're going to translate it. I think that's what you said the other day, Caden, was you said a translation. I like that, because that's exactly what it is. It's a translation, right? So the cube looks like this. 1, 2, 3, 4, 5, 6, 7, 8. 8. I went over 8. 1 over 8, what's the cube root of 8? 2. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. Negative 8, because the cube root of negative 8 is negative 2. Okay. Okay, there it is. Now, let's translate it. So this one we're going to take and move right 2 and then up 1. So, what I'm going to move is what I call the inflection point. So I'm going to take this middle point called the inflection point. I'm going to move it right 2 and up 1, and I'll do the same t-table from there, because I'm just taking the graph and just moving it. That's all I'm doing. Just picking it up, moving it. I don't change its shape. So it's going to look like this. 1, 2, 3, 4, 5, 6, 7, 8 to there. 1, 1. 1, 2, 3, 4, 5, 6, 7, 8. And then it's going to be there. Here's my graph. Domain and range? Well, it's forever wide. So the domain is x is greater than equal, x equals all real numbers. And the range is always going up and always going down. So the range is going to be y is equal to all real numbers also. Okay? Yeah. How you doing? You guys getting it? And you're calm now and quiet now. Thank you. All right, you ready? I'll wait for you. Okay. 17. Okay, ready for 17? We're going to divide by 2, divide by 2. So I've got x to the 2/3 equals 4. Now we've got a couple of choices. What I would do is I would take it to the, you ready? What's the opposite of a 2/3 power? To a 3/2 power, right? If I take this to the 3/2 power and take the 4 to the 3/2 power, then I'm going to get the square root of 4 is 2. 2 to the 3rd power is 8. X equals 8, okay? Or you can see this originally as, let me go ahead and put this on a separate sheet of paper. I want to show you a couple of ways here. Whatever makes most sense to you, okay? 2 times the cube root of x squared equals 8, okay? Same problem. You guys see it's the same problem? 2, bottom number's the root, top number's power, okay? So then divide by 2, divide by 2. I've got the cube root of x squared equals 4, okay? I can cube it, and I've got x squared equals 4 times 4 times 4 is 64. I can square root it, and I get 8 after all, don't I? What? Yeah, John? It is plus or minus. Yes, it is because of the square. X equals plus or minus 8. Thanks, John. I agree with you. Totally agree with you. Okay. 18. I think I better do 18 on a piece of paper too because I'm running out of room. Okay, let's do 18 here, okay? I've got 18. I've got the cube root. Yeah, thank you, Autumn. Of 8x minus 1 equals negative 5. Now, cube roots can equal negative. They really can. We're okay on that. So I'm going to cube it. If I cube it, cancels out the cube root. I'm going to cube this. So negative 5 times negative 5 is 125. Times another negative 5 is negative 125. So I've got 8x minus 1 equals negative 125. Plus 1 plus 1. 8x equals negative 124. No, I don't know. Divide by 8. What is it?
15.5.
I believe you. Negative 15.5. Awesome. Thanks, Autumn. How am I doing? Okay. All right. 19. Okay, 19's got a trick we've got to be careful on. Okay. 19. I've got square root of 2x plus 1 equals 2 square roots of x minus 6. Okay, here's what we got to do. We got to square both sides. It's the only way we can get rid of the square root, but we got to be careful that we square the 2. I'll say this like 3 times. Square both sides. Okay, now I'm going to say this 2 more times. You got to square the 2 because 2 is being squared. Does that make sense? So the square cancels the square root because they're opposite. 2x plus 1 equals. Last time I'm going to say it. The 2, we got to square the 2 and we get a 4. But the square cancels the square root. We get an x minus 6. See how that works? And then it's just a regular old algebra problem, right? So we get a 2x plus 1 equals a 4x minus 24. And just solve for x, okay? We get a minus 2x minus 2x. So I've got a 1 equals a 2x minus 24 plus 24 plus 24. I get a 25 equals a 2x divide by 2, what is that, 12 and a half?
Yeah.
And that answer will work. If I go back and check that answer, if I plug that in, I'm okay. Okay, we're getting close, aren't we? Thumbs up? All right. Number 20. Okay, number 20 and 21, I've got two tricks. So let's do 20 first. Okay, before I do 20, before I do anything on 20, let's do the first part. What's inside can never be negative, correct? So the first thing I'm going to do is this. This is going to have two parts, so two parts. Has to have two parts. First, I'm going to say 3x plus 3 has to be greater than or equal to 0. Where did that come from? Well, we said it. What's inside can never be negative, right? So I said, okay, well, let's make sure it's always positive. Because if it's greater than or equal to 0, it's positive, right? Anything greater than or equal to 0 is positive. It won't be negative. So first thing I did is took what was inside the square root and said, let's make sure it's always positive. Okay, so let's solve for x. 3x minus 3 is greater than or equal to negative 3. Divide by 3, x is greater than or equal to negative 1. Okay, that's the first part. And if I think about my answer, and I plug negative 1 in, okay, think about it. Put negative 1 in, I get 3 times negative 1 is negative 3. Negative 3 plus 3 is 0. That's okay, 0 is okay. But if I put in negative 2, think about it. If I put in negative 2 right here, I'm in trouble, right? I'm going to take that. I'll pass tomorrow. I'm going to wear it. So if you need it, you got to take it off my neck. Okay? That's going to be a bummer for everybody because I'm probably going to say, don't touch me. So now, there's another part, and that is what values are going to be less than 6. So the second part is to take this. I'm going to take my 3x plus 3 and make it less than or equal to 6. So what values of x are less than or equal to 6? Oh, square root, my bad.
Can you just give the...
I sure can. So now, let's solve it, okay? So the second part is just to solve. We're going to square it. I'm going to have a 3x plus 3 is less than or equal to 36. This is the easy part, right? Actually, they're both easy. We just have to remember it's got two parts. If you write that in your notes, it's got two parts. You're going to be in good shape, okay? Minus 3, I've got a 3x is less than or equal to 33. Divide by 3. I've got an x is less than or equal to 11. Now, I have two parts. And if you want to write it like that, but I need both parts, that's fine. A better way to write it is like this. Negative 1 is less than or equal to x, which is less than or equal to 11. That's a better way to write it. And it does say both. You read it backwards. X greater than or equal to negative 1. That's what that says, right? Read it backwards. X is less than or equal to 11. That's what that says, okay? Okay. All right. Last one. Here comes the tricky one. But I know we can do it, okay? All right. So the first thing I'm going to do is square both sides. I've got to be careful, though, because the 4 is also going to get squared. The 4 is also going to get squared. So I square the 4 and I get a 16. The square will cancel the square root. So I'll have an x plus 1. But on this side, anything times itself, anything squared means it's times itself. So I'm going to go, okay, x plus 1 times another x plus 1, okay? Now I'm going to FOIL it. Here, Dylan, why don't you give that to me? So that way, if anybody wants to pass, you got to take it off my neck. Passes. That door is becoming a revolving door, isn't it? Okay. I know. So here we go. I'm going to get a 16x plus a 16 equals x squared plus a 1x plus another 1x plus 1. Combine those two, right? So I've got a 16x plus 16 equals an x squared plus 2x plus 1, okay? Now, it looks to me like I might have to factor because I get an x squared and I get x terms. So what I'm going to do is try and bring over the 16x, bring over the 16. So let's subtract those and make it equal to 0 because it looks like I'm going to have to factor. So if I go minus 16x minus 16x, and if I go minus 16 minus 16, then I'll have it equal to 0 and I can factor, okay? So I've got 0 equals x squared minus 14x minus 15. That'll factor 15 and 1, right? 15 and 1 will make a 14. It's a negative 15, positive 1. So I've got an x minus 15, and I have an x plus 1, right? I get, with many equations, x equals 15, and x equals negative 1. Now I better check, because the negative 1 makes me nervous, okay? So I'm going to go back to my original, okay? If I take a look at my original and plug in negative 1, actually it'll work. Now normally I'd throw away negatives. I normally would. But this time it'll work, because I've put negative 1 up here. Negative 1 plus 1 is 0. That's okay. If I put negative 1 in here, negative 1 plus 1 is 0. I can do that too. So both answers work. Now tomorrow that might not be the case. Tomorrow you might need to throw one answer away, or maybe two, okay? But you should check your answers, okay? Now, that's what I have for today, okay? Thumbs up.